Assalamualaikum. I want to continue our group presentation. Non-destructive testing, NDT. Non-destructive testing, NDT, is used to assess material, component and structure without causing permanent damage or alteration. NDT detect and evaluate defect, flaws, discontinuities or anomalies that could affect performance and safety. It ensures material and structure meet standard in quality control, maintenance planning and failure prevention. Common NDT technique in construction include rebound hammer, resistivity test and rebar scanner. The selection of NDT method depend on material, defect type and specific requirement. NDT provide critical information for maintaining safety, improving quality control and ensuring product and infrastructure reliability. First testing is rebound hammer. Rebound hammer is a portable NDT device for assessing concrete compressive strength. It measures rebound distance of a spring load hammer hitting the concrete surface. The rebound value indicate concrete hardness, which correlate with compressive strength. Data and result. First is Muhammad HAZIQ bin Harun. For total average for column is 24.42 and total average for slab is 19.17. Second is Muhammad SYAFIQ bin RAHMAT. Total average is 22.38 for column and total average for slab is 21.90. Number 3 is Muhammad DANIAL bin HISSHAMUDDIN. Total average for column is 25.36 and total average for slab is 23.04. Next is Muhammad HAZRIN bin Muhammad RASHID. Total average for column is 25.46 and total average for slab is 21.48. And lastly is SHA'ALAHUDDEEN AKMAL bin SHA'ARI. Total average for column is 20.62 and total average for slab is 16.31. This is total average rebound hammer for 5 column. This is 23.65 and compressive strength. You can see this graph for find compressive strength. Compressive strength for 5 column is 12 and this one is total average rebound hammer at 5 slab. The total average is 20.38 and this is graph for total average for slab and compressive strength we get is 12.5. Okay, for summary, rebound hammer test method is based on the principle that rebound depends on the hardness of the rock surface. Average rebound value for slab and column are 20.38 and 23.65 respectively. The rebound hammer calibration chart help determine concrete compressive strength. Based on the average rebound value, the strength of column is 12 and strength for slab is 12.5. Result indicate that slab are slightly strong than column. Column bear heavy load, potentially leading to decreased strength over time. Human error in conducting the rebound hammer test can impact accuracy. Proper technique include holding the tool at a 90-degree angle during testing. The rebound number obtained from the test is arbitrary and dependent on the energy stored in the spring and the mass of the rebound hammer. It is correlated with concrete compressive strength through empirical relationship established via calibration. The rebound hammer test provide an estimate, not an exact value of concrete strength. Accuracy of the test result can be influenced by factors like concrete surface condition, moisture content, presence of reinforced bar, and type of aggregate used. To improve accuracy and reliability, perform multiple tests at different locations and calculate the average rebound hammer. Correlate the rebound number with concrete compressive strength using calibration curve or conversion table provided by the rebound hammer manufacturer. The rebound hammer test has gained popularity since 1948 due to its simplicity and field application convenience. Exercise caution when interpreting test results and consider them in conjunction with other testing methods for a comprehensive assessment of concrete strength. That's all from me. I pass to my member for continue the presenting.
Assalamualaikum warahmatullah. I'll continue the presentation. For next testing is resistivity test. Resistivity testing is a non-destructive method, which is NDT, that does not cause any damage to material or surface and surrounding area. Resistivity test used in building inspection to assess the electrical properties of material and determine their suitability for specific application. This test measures the resistivity of a material, which is the inherent property of substance to resist the flow of electric current. By analyzing resistivity values, engineer and inspector can evaluate the quality, integrity and moisture content of various building material. By accurately measuring the flow of electricity, resistivity testing detects the possibility of steel corrosion and the diffusion rate of chloride within the concrete. This experiment required 5 members to testing the building where column and slab are included. The testing was conducted at Block A2 Unicity. The apparatus for the equipment for this experiment is we use a support resistivity meter, model H2879.X. For the first member, HAZIQ, total average that it got is 1158.167. For column and slab is 810.8889. For the second member is SYAFIQ, which is me. For column 968. For the slab is 1175.333. For the third member, Daniel, total average for slab is 1200.722. For the column 1028.722. For the fourth member is SHA'ALAHUDDEEN, total average for column is 565.7778. While slab he got 1036.667. For the last member, HAZRIN, for the total average for column is 691.333. For the slab 1241. For the total value of column, which is total average for 5 members that we got, is 880.4 for the column, and for total average slab is 1092.92. After we got all the result, and data, I can conclude I list the 3 reasons why the difference of value. Based on the result, first, one possible reason for the varying sensitivity value between the column and slab is the difference in the material used. The column and slab might be made of distinct material, each possessing unique electrical properties. For instance, the column could be composed of a material with inherently lower resistivity, resulting in a lower average value compared to the slab. Second, contamination within the material can also affect resistivity measurement. If one of the samples, either the column or the slab, has been contaminated with conductive particle of impurity, it can lead to a higher resistivity value. It is crucial to ensure the samples are clean and free from any contaminant that might influence the test result. And the last, the resistivity value may vary due to the size and homogeneity of the sample tested. If the column and slab sample differ significantly in size of composition, it can affect the resistivity measurement. That's all from me. Thank you.
Hello, my name is HAZRIN bin RASHID. My metric number is 20133-2019. For this mini project, I will explain about riba scanner, which is a non-destructive test. For introduction, riba scanner is a non-destructive test or NDT device used to locate and measure the position of reinforcement bar in concrete. There are two main types of riba scanner, which are electromagnetic, which using magnetic field to locate the bar, and ultrasonic wave, which using ultrasonic wave. The application of riba scanner can be divided into four, which are construction, to ensure that riba is properly placed and that the concrete cover is the correct thickness. For repair and maintenance, riba scanner also can be used to locate riba that need to be repaired or replaced. For forensic, it also can be used to investigate the cause of structural failure. And lastly, for demolition, is to identify the location of riba before demolition works begin. The application of riba scanner can come in benefit and limitation. For benefit, riba scanner is a non-destructive testing method, so it does not damage the concrete. It also a quick and easy way to locate riba. Riba scanner also can provide accurate measurement of the position and size of riba. Lastly, it also can be used in variety of applications, including construction, repair, maintenance, and demolition. But it also came in limitation, which are not able to detect riba that are covered by a thick layer of concrete. It also not able to detect riba that are made of non-ferromatic material. And lastly, riba scanner also not be able to detect riba that are damaged or corroded. For this mini project, we conducted the riba scanner, and to summarize, this testing conducted at the concrete floor of A2 block in University Island campus. The data was collected for 7 bars horizontally and vertically, providing insight into the spacing and the depth of rebar. For the horizontal rebar, the spacing between the rebar ranged from 205 mm to 350 mm. For vertical bar, the spacing ranged from 75 mm to 110 mm. The bar diameter found at the A2 block is 16 meter diameter, 16 mm diameter, and concrete cover is 50 mm diameter.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHD HAZRIN. I'm a member H2 Today I want to present about my part, which is scaffolding. Scaffolding is a temporary structures erected on construction sites or in the other industrial setting to support workers and materials during building maintenance or repair projects. Primarily used to give workers a secure and stable platform from which to carry out construction-related tasks like painting, plastering, bricklaying, electrical work, and other related tasks. They have 4 functions of scaffolding. First is access, second is flexibility, third is safety, and fourth is support. Next, we go to the type, advantages and disadvantages of scaffolding. First type is a single point scaffolding. Uses a single vertical member supported by cantilever projecting from the structure site. The advantage is easy assembly and dismantling, cost effective, quick access to work areas also lightweight and portable. Disadvantage is limited load bearing capacity, less stability compared to other types, and requires a secure anchoring point. Next is suspended scaffolding. Suspended scaffolding is a platform suspended by ropes or chains from an overhead structure. Advantages: ideal for work at height and tall structure, flexibility and adjustable height, easy access to vertical or overhead areas, and unobstructed views for workers. Disadvantages: it requires skilled workers, not suitable for high winds or adverse weather conditions, and relies on a strong anchoring system. Next is the steel scaffolding. It is constructed using steel tubes and couplers. Advantages: highly durable and strong, support heavy loads, excellent stability and fire resistance, also easy modification and extension. Disadvantages: relative expensive, requires specialized equipment, also heavy, and may require machinery or manpower for transport. And lastly is the modular scaffolding. It is utilized prefabricated component. Advantages: easy assembly and disassembly, versatility for different project needs, excellent stability and load bearing capacity, and safer working conditions. Disadvantages: initial investment for components, requires proper planning and expertise, and is not suitable for irregular or complex structure. That's all from me. Thank you.
Assalamualaikum. My name is SHA'ALAHUDDEEN and I will be present destructive test part. Mechanical tests that physically damage the material being tested are known as detective tests. The strength, toughness, and other qualities of material are assessed using this kind of testing. Curing and compressing tests are known as two basic categories of detective tests. A cylinder sample of material is taken from a bigger portion during a test procedure known as curing. The sample is subsequently put to a compressive tank to ascertain its compressive strength. A sample of material is compressed during a test called compression test until it breaks. The force necessary to break the sample serves as a measure of the material compressive strength. A physically destructive test approach might determine the following steps. Test setup. The test apparatus or equipment should be set up. Make sure it can apply the desired load or stress on the test specimen. Utilize a load frame, a hydraulic press, a universal testing machine, or other specialized apparatus may be required for apparatus setup adherence to the manufacturer instruction. Instrument install any equipment or sensor required to monitor and keep track of the test parameter, strain gauge, load, cell, displacement, temperature sensor, and other measurement tool may be used in this check and the instrument correctness and capability. Test planning. Identify the test goal, include the trail or qualities that will be assessed and the particular test procedure that will be applied. Take into account the necessary equipment, safety procedure, and any applicable standard or specialized. Sample preparation. Create the sample specimen in accordingly with the requirement and dimension given in order to achieve the desired shape and size. The sample may be need to cut, trim, or construct. Make the sample accurate representative of the substance of component being examined. Pre-test inspection. Visual examiner the test specimen to look for any abuse, flaw, surface, blemish, or other abnormalities. For future reference, note and record the specimen state. Test executing. Execute the test by apply the load or stress to the test specimen in accordance with the established test protocol. In order to do this, the specimen may be loaded in several ways, include testing, tensile, compression, bending, torsion, impact, and others. To the test regulation and keep an eye on the test parameter. Data collecting. To the test continually gather the record the data coming from the instrument. This contain the amount of force or load applied as well as any relevant measurement of strain, temperature, deformation, or displacement. Use the proper software or data system. Failure analysis. Failure analysis involves tracking the test specimen behavior up until failure. Any indicate or deformation, crack, furniture, or other failure model should be noted if required. Record a video or take a picture to document the evolution of the failure. Data analysis and reporting. Examining the failure specimen closely after the test to learn more about the failure mechanism is known as post-test examining. This could entail photography, chemical analysis, microscopic investigation, or other method. Take note and picture of the outcome. Data analysis and report. Examining the information gathering to assess the material or component performance. Determine the attributes that are important like strength, stiffness, toughness, or furniture life. Create a thorough report. Include a summary of the test, observation, and finding. The advance of destructive test is comprises data quality assurance, design optimize, safety assessment, research and develop. Destructive testing offer a thorough and in-depth insight of the mechanism, characteristic, performance, threshold, and failure mechanism of a material or component. Engineer can learn more about specimen behavior under variable load sustained by purposefully put it at risk of failing. For correction material, characteristic, product development and design, optimizing this information is externally detective test is a crucial component of quality ensure procedure. It's seen in local material problem, manufacturing issue, or design flaw that may jeopardize the integrity or safety of the product by subjecting sample to regulation load until failure. Is guaranteed that the finishing product comply with the necessary industry standard and requirement. Detective tests offer useful information for improving design. Engineer can find weak spot, stress spot, or propertive impression improvement area by purposely staining a material or component to its limit. Utilizing this knowledge will improve product performance, boost reliability, and optimize design for particular application. Destructive test is necessary for evaluation the strength and safety of part or structure. Engineer can identify the load-bearing capacity, failure site, and failure model by putting sample under increasing load until they fail. This contributes to the general improvement of safety by ensure that the structure can resist planet load and prevent catastrophic breakdown. The disadvantage of destructive test is cost and time. Limit sample size, availability, lack of real-time monitoring. Detective tests may be expensive and time-consuming. The delivery destructive of sample, the requirement for number sample, and the number of testing iterating can all great rise the cost of testing. As a whole, additional the amount of time needs to prepare the sample, carry out the test, and analyze the preparation sample, carry out tests, and the analysis result can be significant, which could affect the time frame for the project. When conduct detective testing a sample must often to take from a large population or building. This could result in a resisting on representativeness, particularly if the material or components show a lot of variation. To product accurate and valid result, care must be taken to guarantee that the chosen sample accurately reflect the entire population. After ongoing destructive tests, a specimen is rendered useless and cannot be retested. When working with constant resource, or when the sample is priceless or irreplaceable, this may be limitation in this sequence. Non-destructive test technique may be used since the anal evolution without resulting in long-term harm. The statistics test does not offer real-time feedback while it is being conducted, since the data is often collected after the test. Any deviation or anomalies may not be found, noticed, or rectified. It is frequently impossible to monitor metrics like load, displacement, or strain in real life time, which may restrain the capacity to change the test condition quickly. The statistics test, sometimes referred to as mechanical testing, entails applying a control load or stress to a material or component until it breaks. This kind of test is done to determine a material or structure mechanical characteristic, capability, and limits. Few common applications for detective tests. Material testing. Detective test of material is used to certain their mechanical characteristics such as tensile strength, yield strength, durability, hardness, impact resistance, and furniture resistance in sectors including aircraft, automotive, construction, and manufacturing. These tests are critical for quality control, material selection, and design objectives. Structure testing. The static test is used to evaluate the strength, load-bearing capacity, and structure integrity of a structure elements such beam, column, and brick. Engineer can accurate establish information for design, optimization, safety, evaluation, and lifespan predicting by subjecting this structure to control load until failure. Product development. The static test is frequently performed to evaluate the functionality and robustness of prototype or novel design during the product development process. Engineer can find which place a change design element and make sure the product comply with specification by deliberately pushing it to its limit by researching the failure mechanism. Welding and joint process. Destructive test is used to assess the effectiveness of welded connection and other kind of material joint process for the safety and durability of welding structure. Tests like bend test, tensile test, and impact testing are carried out to evaluate the strength, integrity, and weldability of the joint. Failure analysis. Destructive tests can be performed to look into the underlying cause of a component or structure. Unexpected failure. Engineer can identify whether the failure can caused by material fault, design fault, manufacturing error, or other issue by putting the failure component to control test. This research offers insightful suggestions for extreme upcoming design procedure and safety protocols. That's all. Thank you.
As conclusion, a reverse scanner is a non-destructive test. It can be applied for construction, repair and maintenance, demolition and forensics. The method doesn't damage the concrete, an easy way to locate rebar along with the position and size. But rebar scanner can detect rebar that are damaged or corroded, made of non-ferromagnetic material and covered by thick concrete cover. The test conducted for this one project at A2 block of University Alam campus, which detect the layout and the size of rebar. The irregularities found, which the range of spacing may caused by the equipment and human errors during the testing. That's all for me. Thank you.